So it's been a little while since we've seen these, but I'll do a bit of a review. Abby's drawn some beautiful triangles here, but I draw mine a little bit differently. So I'll draw these up above my working here. I've got the 45-degree triangle that Abby has, which is pi on 4, pi on 4. With these, what do we always label our shortest side? 1. That's my shortest side, correct? Have I got another side that's also that short?
Yeah.
By nature of a 45-degree triangle, as you go across one, you go up one, which means that this will be root 2 using Pythagoras. Interestingly, 45-degree goes across one, goes up one. I wonder what, no, a different angle. Let's pick a different angle. This one here. What's the angle there? 60, which is pi on 3, and this is pi on 6 up here. So what's the gradient of that line in degrees? 60 degrees, correct? I'm going to make my shortest side 1. What's the other side? Root 3 and 2. If my angle wasn't 40 or 60 or 30, I would have to use my calculator to solve this, correct? The whole reason we do this is because we have exact triangles that we use to solve trig problems without calculators. So the first thing I do is I look at this problem here, my first one, sine pi on 4, and I ask myself, what's the first question? What's the first question I ask myself? Jerry, what do you reckon?
Sorry, which question is this?
What's my first question when I look at this problem? I've got my triangles drawn.
Find pi with 4 model triangles, and then...
So before I do the pi on 4, I need to ask myself what something is in.
What quadrant?
Quadrant. What quadrant is it in? So this one is in quadrant 1, correct? So I always like to draw it because drawing makes our life a bit easier. Sine equals
Pi over.
opposite over. I hope we know what sine equals. If we're not sure, I can ask my year 9s, they're pretty proficient. Opposite over hypotenuse. So I'm going to pick one of these angles. I'm just going to pick this one here. My opposite is?
1.
Adjacent, hypotenuse is? Root 2, so it's 1 on root 2, correct? Which I can represent as? Root 2 over 2. Just be aware of that. Are we happy with that? Question 2. What quadrant am I in? First quadrant, very good. Less than half a pi, correct? Must be in the first quadrant. Which triangle? First one or the second one? Second. I need cos, which means the adjacent over the hypotenuse. What's my adjacent to pi on 6? Root 3 over?
2.
Do I need to rationalise the denominator?
No.
All good. And the third one. What quadrant am I in?
2.
Quadrant 1, 2, or 3, or 4? Quadrant 1. What triangle? First or second? Tom?
Second.
Second. What do I want for 10?
Over A.
Over A. What's my opposite to pi on 3?
1. No, 3. Root 3.
Root 3 over?
1.
Which I can represent as?
Root 3 over 3. No.
What's a Tom divided by 1?
What's what?
What's 1 Tom divided by 1? So what's root 3 divided by 1?
Root 3.
Very good. So, first 3 we're all dealing with quadrant 1. That was pretty good there, correct? We're pretty happy with that. What happens when we go to the different quadrants? What do we have to identify? How far off the nearest horizontal, correct? So 7 pi on 6. Which quadrant am I in? Let's do with that first of all. Third. I'm more than a pi, correct? I'm a little bit more than 1 pi. How much more than 1 pi am I? pi on 6. So if I'm drawing that, I draw it all the way around to here. The only part of the angle I care about is which part? This little tiny bit here. That's the only part I care about, which is probably why I should have left that there and done this instead. I only care about the fully coloured in part. How big is that angle? Pi on 6. What quadrant am I in? Third. So, my working should be sine 7 pi on 6 equals negative sine, what? Pi on 6. Now we're very good at dealing with that problem, aren't we? We've just done one very similar. What triangle? First or second? Second. Sine equals?
1/3. No, second.
Sine equals? Opposite over? What's my opposite? 1 over? Does that make sense? Question 5. Same process. I ask myself. 13 pi on 3. I can break this up into pi segments. This is 3 pi on 3, correct? 6 pi on 3. 9 pi on 3. 12 pi on 3. Plus pi on 3. Do I care about all the rotations prior?
No.
So the only thing I really care about is the fact that this last little bit here, that angle there is equal to pi on 3. Should be bigger than that, but anyway. So what's my next line of working? Cos 13 pi on 3 equals. Fill that in for me, I'll tell you in a second. 5 seconds. Cos 13 pi on 3 equals? Cos pi on 3, correct? Positive, we're in the positive quadrant for cos, any positive for anything. What's pi on 3 equal for cos? Adjacent over? Hypotenuse, what's my adjacent there, Caleb? 1. What's my hypotenuse? 2. Very good. And lastly, when we're dealing with negative angles, what does that mean? Thank you. Harriet, negative angle. Goes the other way. So normally our angles work anti-clockwise, negative angles work clockwise. What quadrant am I in then? So if I'm going 2 pi on 3, bigger than a half or less than a half?
Bigger.
Bigger, so I should be beyond that line there, correct? I'm going to be there. How far off the nearest horizontal am I?
1 pi on 1.
Pi on 3. What quadrant am I in? Third is tan positive and negative. So what's my next line going to be? That equals? Tan pi on 3, negative or positive? Positive. I've already done that one, I don't even need to redo it. That equals, Tom? Root 3, very good. Root 3 over 1, which we can write as? Root 3, very good. Clear with that? Would you like a couple more to practice on, or we're happy with that? This is the sort of thing that does come up in a tech-free exam as you go forward. You need to be sharp with your skills. There's also a few other things you need to know. A few other key values that we don't need triangles for. What's some values I could ask you about that don't involve exact triangles? Yeah, so with dealing with sine and cos, what values? What angles?
30, 60, 90.
Yeah, but they're the exact triangle ones? What, you said one that wasn't though? 180, that's one. 270. What else? 360. 90, correct? So before we go any further, what I want you to do, and I'm going to do it in radians, I want you to go cos of 0, cos of pi on 2. I just want you to fill those out, see if you can get them all right. And cos 3 pi on 2, cos 2 pi. And then do the same for sine for me, please. So fill those out. And that's a lie, actually. I want you to do one more. want you to do sign, I want you to do 10. Fill them out for me, just so we're aware, if you can do those all by yourself, you're in a pretty good spot.